Hi guys, BuildZoid here, and I don't really have anything specific to show you, so instead of doing a talking head video, we're gonna do a drifting car video while I talk about some topics about relating to precision boost overdrive and mostly the which I just like I have a paper with the notes for this, and now I don't know where to put it. Anyway, we'll throw it over here. I'll be able to see that. Anyway, so yeah, like honestly, you can probably go do something else while listening to this video. I'm not going to be showing you anything interesting. I'm just going to be talking about stuff, mostly relating to the, the videos that I've been doing with the whole easy way to get a bit more performance out of Ryzen 3rd Gen on various motherboards from various vendors. So, first up, I'd like to talk about the EDC bug, right? Which is basically when you set your EDC limit really, really low. So you'd run PBO settings that look like, say, well, I've heard of people doing 001, but I've also seen people doing things like 175, 120, 25, 175, 120, 10, 170, like 300, 230, 10, 300, 230, 25, 300, 180, or you get the idea. So a bunch of different combinations, but the thing that makes all of them work is that the EDC setting is like 2 digits or even 1 digit, right? Where it's just 1 or 4. I think, yeah, I've seen some people say that like 4 works for them. So I have heard about that. I've read the thread on overclock.net. My experience with it is that it's horribly unreliable. So what do I mean by horribly unreliable? Well, getting it to work on basically most any motherboard I have is just not a very pleasant experience. So with my 3950X, a lot of the time, if I tried to do the EDC bug, what happens is I lose a bunch of performance. It just ends up being slower than stock, which is obviously not good. So, but, you know, if you fiddle with the settings for long enough, eventually you get something that's actually faster than stock. But how much faster than stock is it? Well, it's about the same speed, at least with my CPU. It's about the same speed as if I just punched in 300, 230, 230, or there's one other setting combination, which is 300, 180, 180. But we'll talk about that later, like, because that's going to be like a separate topic. But yeah, so it doesn't actually score like for me. I've not had the 3950X. Like even when I got the EDC bug to work on the 3950X, I've not seen scores that are better than just maxing out the PBO limits to the extent that you can max them out, because obviously if you punch in something really, really high, like 555 for every single one of them, or, you know, 999, or just you blow out the limits completely, they glitch out and you actually lose performance. So, you know, that's kind of the thing. So the EDC bug, like, I've not been able to reliably get it to work on the 3950X, and when I do get it to work, it doesn't score any better, so it doesn't make sense for me to recommend to people to use this bug, because there's also a chance that in an AGSA update, eventually it'll get removed. Depending on what BIOS version, it won't work reliably. Whereas if you're on AGSA 1004B, that's the AGSA where it's like if you punch in too high values, that everything glitches out and it's awful. And to some extent, 1003 ABBA does it too, but it's not quite as bad as 004B is with it. But on but the thing is like if you punch in 300, 230, 230, that will give you the same results on every single AGSA. And they're, you know, they're not necessarily the fastest results, but they're really consistent. And I like that because it's like, yeah, you can punch this in and it's pretty much guaranteed to work, except if you have an ASRock motherboard, and we'll get to those. So yeah, so my experience with the 3950X and the EDC bug, unreliable, doesn't actually score better, not worth recommending to people to try do the EDC bug when I can't get it to work in any way that would actually be like impressive. That is not to say that I haven't seen all the posts from people who are like, oh, my chip scores, like, I've seen a screenshot of somebody's 3950X spitting out 9900 Cinebench R20 on PBO, which is like, Like, that's like 150 points higher than the best score I've ever seen out of mine. But I think that's also down to the silicon lottery. So maybe if you have a really lucky CPU, it just scores better, which makes sense because the boost system is it's a boost system, right? It's not like it's not like when you have a CPU where it's like specified to run at 4 gigahertz and therefore it will always run at 4 gigahertz. It's like it will run at any frequency between base clock and 4.7. Well, in the case of my 3950X, I've seen that chip on very, very light workloads, like, say, doing this with the mouse, just spasming the mouse around the desktop. Yeah, that makes my 3950X go to 4.75 gigahertz quite consistently. So very, very light workloads, like my chip will go anywhere between base clock and 4.75 gigahertz, depending on the workload. Right, and if you have a chip that has better silicon, well, it's going to be on the upper end of that frequency range rather than the lower end. And if you have a terrible chip, it's going to be on the lower end rather than the upper end, which is great. So there's going to be some variance going between chips just at stock. But AMD obviously only guarantees base clock performance because that's what's on the box. Right? Like, that's the whole point of specifying a base clock, is like, the chip will not go below X unless it's like not being cooled adequately. And anything outside of that is just like, well, technically it's up to. So, you know, that's kind of that. So that's my experience with the 3950X. With the 3700X, for the most part, it's very similar to the 3950X in terms of the EDC bug, where it's like most of the time it just doesn't work and I lose a bunch of performance. On ASRock motherboards, the chip crashes outright. So it won't, like, like, either I lose performance or it just crashes. So on ASRock motherboards, my 3700X has literally never actually seen a performance gain. On MSI motherboards, well, I've not been testing the 3700X on MSI motherboards because I think I degraded the chip, as it's no longer capable of running Prime 95 on MSI motherboards. It runs Prime 95 on other motherboards, which is kind of interesting because on MSI motherboards specifically, actually all of my CPUs, which that being the 3950X and the 3700X, score a bit higher in Cinebench than on any other motherboard I have. The downside is, well, the 3700X won't run Prime 95 on MSI motherboards, whereas it will run Prime 95 on literally any other board. It just won't do the EDC bug on any other board. So on Gigabyte, I've just not managed to get the EDC bug to work on the 3700X at all. And on ASRock, well, it just locks up the system. On Asus, it ends up being the same as my 3950X, where it's like, most of the time, you know, it loses performance, but if you do fiddle with the settings long enough to get it working, then it's like, it scores about the same as if I just punch in 300, 230, 230. So that's why ultimately all of the easy way to get a bit more performance are just 300, 230, 230, and they ignore the EDC bug because it's just too unreliable. Plus, because it's a bug, there's a chance like the next AGSA will patch it out, and then it's like, oh, and now the videos are relevant. So, which is always a risk with anything that relies on an automatic boost system made by AMD, where it's just like, well, maybe one day they'll change how the algorithm works, and suddenly all your settings are invalid. Which is kind of what happens with like settings that work, like boost just fine on ABBA. They're like, if they're high enough on 004B, they're just gonna they're just gonna power throttle for no reason, which is just like, good job AMD. Who doesn't love who doesn't love BIOS updates that drastically change the performance behavior of the CPU, right? Who doesn't love that? So in other news, 004B breaks memory training on some motherboards, and some other motherboards are fine, but it's just great. Like, they seemingly they seem to have adjusted something with the memory controller, and so yeah, on some boards memory training is a lot more difficult than it used to be on ABBA. Anyway, so that's the EDC bug with both the 30 like, it's just unreliable. So I'm not gonna recommend it in videos that I'm very specifically aiming at beginners with. So the next thing is, there are actually PBO limits that do work better than the 300, 230, 230 that I use. But it's kind of like, so one set of limits for my 3950X, one set of limits that, at least on Gigabyte motherboards, because on MSI motherboards, for whatever reason, this doesn't apply, but on Gigabyte motherboards, instead of 300, 230, 230, if you want a slightly higher Cinebench score, you can try using 300, 180, 180. And that'll boost the Cinebench score by about 100 points. The downside is you lose about an equivalent percentage in terms of performance in IBT. So, you know, you get like 1% more performance in Cinebench, and you lose about 1% in IBT. So it's just like, well, that's great and all, but evidently the benefits of that seem to be very workload specific. So I guess if you run mostly lighter multi-threaded workloads, 180, 180 is probably for the best on Gigabyte motherboards. But if you run really heavy workloads, you probably want to run 230, 230, or just do a static overclock. And we will talk about those as well in this video. So that's a thing. Then with the 3700X, somebody suggested to me, I believe it was like 175, 120, and 105, or it was 105, 120. I can't remember which order the current limits were in, but it doesn't matter. The point is significantly lower than my settings, and those settings actually consistently increase performance by about 1% across all workloads, which is neat. So that's, that's good. But it's about 1%, so not really, like, admittedly, like, with how Ryzen, with how limited the overclocking range on Ryzen is in general, it's like, okay, well, 1% is actually kind of significant, considering that most of the time you're looking at performance gains in the 5% range, so, 5% versus 6%, well, that's a 20% increase, but at the same time, it's like, that's a 20% increase in percentage, but still, it's 1% more Cinebench and 1% more IBT. Which leads me to believe that there's probably optimal settings that aren't like 300, 230, 230. Like, the way I came to these limits was I ran Prime 95 on the 3950X, and I was just looking at what got the highest boost in Prime 95, because my logic was, look, if it boosts, whatever delivers the best boost in the heaviest workload should also deliver the best boost in all workloads. Well, that's obviously too simple-minded thinking for very advanced boost algorithms like AMD's, which just do things for reasons no one can explain. So evidently that doesn't work. So what works best for Prime 95 evidently doesn't work best for Cinebench, and what works best for Cinebench probably doesn't work best for some other random workload. Yay! So that's really annoying. But the other thing is, there's also a good chance, like, the thing is, when I came up with that 300, 230, 230, I went and then tested that 300, 230, 230 on my 3700X, and basically I was just like, okay, well, the 3700X now does perform better than before. Therefore, I am going to just use 300, 230, 230 for all CPUs because, well, there is some performance uplift. Apparently, it's not the maximal performance uplift because, again, there seems to be optimal power settings for, like, every workload and probably every CPU as well. Though I do believe, like, 230 is a hard limit of the AGSA, where if you go above that, it just glitches out and does stupid things. As in, you lose a bunch of performance. But, yeah, the thing is so there's probably like a 3900X, I would assume, has a peak performance at around like 170. And peak Cinebench is probably around 150. But peak performance Prime 95, you're probably looking around 170, 180. We need to dodge that player. Okay, good. There's collisions on this server. So, anyway, 180... Yeah, so with the 3900X, there's probably a different set of limits that works well. With the 3800X, there's probably a similar set of limits to the 3700X, but it might be slightly different, because the 3800Xs might be binned a little bit differently, or just something due to what clock speeds they're capable of running. They might prefer higher limits or slightly lower limits. And then 3600Xs would probably be like 80 or 100, where they hit peak performance. So there's a chance that there are, well, not a chance. I think it's very likely, which technically is a chance, so whatever. I'm very good at English. Anyway, so yeah, basically there's a good chance there's like specific per CPU limits that are optimal, but I don't have all the different CPUs, and I don't want to make a video where I just go like, oh yeah, but if you have a 3900X, then you probably want to try different limits, and not have a specific number in mind of what those limits would actually be, because the whole point of those videos is that you can take those settings, punch them into your BIOS, and just roll with it. Right? Like, you should still, in my opinion, run at least a memory stress test overnight, because you never, like, in theory, XMP should never be unstable. In practice, that is less than true. Right? Like, that is general, like, depending on what XMP, what memory kit, what motherboard, what CPU, there's a good chance that you're gonna not be stable at XMP. Well, it depends on the XMP, but, like, there's definitely a chance that it's not going to be stable, and obviously there's also the chance that you're just going to get a DOA memory kit, right? Like where it's dead on, like just defective from the factory and it just doesn't work, and then you run memtest and memtest will tell you, yeah, this memory is not stable. Which is always fun, because then you have to get into the whole like getting the memory vendor to acknowledge that it's actually the memory kit and not your motherboard or your CPU that's causing the issues. But anyway, yeah, so the point of those videos is that they're like fire and forget settings, and if I don't have fire and forget settings for every single CPU, then I'm just going to go with the settings I like. Sure, they're not optimal, but they do still work, and that's good enough in my book, right? Like, yeah, you could probably get, instead of a 3.5% performance gain in Cinebench on a 3700X on a stock cooler with a slightly different, like with different current limits, you might be able to do 4.5% more performance instead of 3.5% more performance. But at the same time, I don't know what the, like, well, for the 3700X, I could figure out the optimal limits, but for like a 3900X and a 3600 and a 3600X, I can't, because I don't have those. And so then it's like, well, just use 230, because 230 works, right? It's just not optimal. So that's kind of the thing with the PBO limits. So the next thing I want to talk about that a lot of people mentioned is negative voltage offsets. And I'm fully aware of negative voltage offsets. If you may remember, I did a video about how negative voltage offsets are like the best way to get, like the most convenient way to get more performance out of Ryzen 2nd gen. Because if you set a negative voltage offset, you suddenly, like, it would boost more and you'd get more performance, which was great. Now, with Ryzen 3rd gen, in all of my testing, negative voltage offsets lower power consumption. They do that. They improve your temperatures. They lower power consumption. They improve your efficiency. What they don't do is they don't reliably raise performance. Or really, I've never seen a performance gain on either my 3950X or my 3700X. Voltage offsets as low as minus 125 millivolts, and the only thing that happens is the power consumption goes down, the performance stays the same, and if you set the offset, actually, I've tested all the way down to the point where the chip just blue screens outright, where you're looking at offsets like minus 150 or minus 200 millivolts, and depending on the motherboard, and I think depending on the CPU, like I've heard of some people where it's like they use a negative voltage offset and they lose performance. My experience is if I set it too low, it just blue screens. Or, well, Ryzen doesn't really blue screen, it black screens, because for whatever reason, these CPUs, when they lock up really hard, and it just takes the whole system down instantly. But, yeah, so the voltage offset thing, I was really strongly considering including voltage offsets in those videos. But ultimately I came to the conclusion, well, considering that voltage offsets can cause major instability issues, as in the system literally just goes down, recommending an offset like minus 100 millivolts without knowing, like, I don't know for a fact that that's going to work on every single CPU. Honestly, even recommending 3600 megahertz memory is like, I've heard of chips that don't do 1800 megahertz FCLK. So, it would be, say, like, if you want to be extra lazy, you'd actually want to run like a 3466 kit instead of a 3600 kit, but just in case your chip isn't good enough. But with the voltage offsets, I feel like that's far more likely that you're going to run into like weird issues, like say the performance losses, like say you know, the system locking up, that kind of thing. Or black screening, because it's not really a lockup. It's not like it stops responding, it just stops putting out an image. So because of that, it's like, yeah, so maybe a very mild offset, like 25 millivolts, is probably safe for all CPUs, regardless of motherboard used, regardless of cooling used, regardless of silicon quality. But the concern is, but then the thing is, like, but minus 25 millivolts is also just not going to do a whole lot of anything. It's not really going to significantly lower your power consumption. It's not really going to do much to your temperatures. So why even bother with a voltage offset that low, right? So if you do want to put the time in and tweak negative voltage offsets, go for it. I think that's a totally valid way of improving the efficiency of your Ryzen 3rd gen system. But I don't really think, like, I don't see the point in including that in the videos when I've just not seen it make performance gains, and there is a very real risk of it causing crashes, right? So that's the thing, is just like, that's why there's no negative voltage offsets. Though I do, like, out of all the out of all the things you can mess with on Ryzen 3rd gen, negative voltage offsets are probably the best idea. Now, what else did I want to talk about? Offset, yeah. So, since we're already kind of on the topic of voltages with the negative voltage offsets, let's talk about static overclocks. That's a great transition right there. So static overclocking. So with my 3950X, the first static, like, basically my approach to static overclocking on Ryzen 3rd gen is like, whatever voltage the chip will run in Cinebench, all core, is what I would idle at. Okay, because the main concern you have with Ryzen 3rd gen when doing static overclocks is that there's no power management. Like, by design, those chips will turn off all of the power gating, all of the, like, any smart power management that's running in the PBO system, like, that's disabled as soon as you change the CPU ratio. Like, if you change the CPU ratio from stock to, like, from auto to, I don't know, 37.75, right? Which I know for a fact is not a base clock for any CPU. Because if you actually set it to base clock, the boost system is still active. But yeah, so you manually set the frequency to some, you know, anything other than base clock. It disables all of the power management. Like, it's just gone. And so then the concern is like, well, if the chip has all of its power management running and you're running a single core workload, there's a good chance, and you know, it's applying like 1.45 volts to itself, right? Because Ryzen does that. And it's not probably, like, that 1.45 volts is probably not hitting all of the cores at the same time, right? Actually, it's not even probably, it's almost certainly not hitting all of the cores. Like, it's probably hitting the one core that's currently busy, and everything else is sitting at effectively 0 volts, because it's just power gated off. Which might be a really gross simplification of that. But anyway, yeah, so the concern there is, like, I really, and the thing is, for me, the 3950X, it's very, very expensive, and I'm not going to break it. The other issue is just, like, idling really high voltage, like, say, 1.4 volts, like, I'm going for Prime 95 stability with my overclocks. And, you know, if you're going for Prime 95 stability, then it's just like, well, the fit limit on my 3950X for Prime 95 is 1.23-ish volts, which basically means, yeah, I'm not gonna, like, there's no point idling at 1.4 volts if I'm gonna V-droop all the way to 1.2, right? Like, there's no point, like, there's benefit to having some droop, but if your motherboard is good, there's no benefit to having 200 millivolts of V-droop. Okay, so that's kind of that, you know. And if your motherboard is terrible, I would just not static overclock in the first place, because static overclocks are definitely the best way to pull even more power than PBO can. Yeah, so because of that, so that's why the 3950X, you know, I have it set up to be 1.34 idle, and well, actually, it's not even going to idle at 1.34, because, like, idle, like, that, if you have some amount of V-droop, that 1.34 volts you set in the BIOS only applies if there's 0 current flow, which like, if the chip is running, there's some current. Therefore, there is some droop. And if you punch in 1.3, which it's not even 1.34, it's 1.3375, well, it's going to be probably idling at like 1.335, 1.33, just because there's some amount of idle current draw. And that's like barely above what the chip runs for all-core Cinebench, so I feel very confident running that at idle, because, well, if it can run all-core workloads at that voltage, then it should be able to run my desktop at that voltage without degrading. But for comparison, my 3700X I've not been very gentle with at all. I regularly, like, I've run stress tests on it at 1.375 because the chip is terrible and that's the only way I'm getting it to do. Like, if I want to run 4.2 gigahertz at all on that chip, it needs over 1.35 volts. So that thing is junk, and it was always junk, and I think it's getting worse. So, because of how much voltage I've been just ramming into it to try get it to suck less. Yeah, which is probably why it just straight up, like, crashes on, like, it can't run Prime 95 on MSI motherboards at stock or with PBO or with anything. It just can't run Prime 95 on MSI motherboards. Like, obviously I could run a static overclock and then just, you know, configure that to be low enough frequency that Prime 95 would run, but at stock settings, that chip is no longer stable on MSI boards. It is stable on Asus and Gigabyte, but and also ASRock boards. But on ASRock boards, if you try to do the EDC bug, it completely crashes. And on Gigabyte and Asus, well, the EDC bug doesn't really work with that chip at all. So, yeah, but... So with the 3950X, I'm being very, very careful. And one thing I've been wondering about the static voltages is that the way Ryzen within its own boost system applies voltages implies that it's relatively robust to, like, voltage-based degradation, but not necessarily current. So, in theory, if you have a 6-core CCD instead of an 8-core CCD, you should have a higher fit limit in terms of voltages. So, like, running running more voltage into a 3600 is going to be safer than running the exact same voltage into a 3700X, just because a 3600 is literally incapable of pulling as much current as a 3700X. Like, a 3700X can pull about 100 amps, which, you know, in Prime 95, which is like 12.5 amps per set of per core. But if you look at a 3600X, and that's at like 1.2 like upper 1.2 volts range for that 100 amps figure. But if you look at a 3600, well, it literally has 2 cores less. Therefore, about 25 of those amps are just going to be missing, right? Like a 3600 is going to pull 25% less current at any given, like, assuming similar core, like, silicon quality, which I did a leakage, well, I tried to do a leakage test. I'm not sure how accurate it is, but at the same voltage, same frequency, my 3950X and 3700X pull, like, the 3700X pulls, like, I think 2 watts more, or 3 watts more, something like that, like, very slightly more power. But it was also a relatively low voltage, and if you want to boost leakage, like, just run a higher voltage or a really high temperature. And it was like a, you know, relative, like, I'm being careful with the 3950X. I'm not breaking that chip for any time soon. Like, I've just decided I'm not doing anything stupid with it. But yeah, with a 3600, assuming similar silicon quality, you shouldn't, like, you'll be pulling 25% less current at the same voltage and frequency, which, assuming, like, I'd assume if you ran Prime 95 on a 3900X or a 3600 or a 3600X, because all of these have 6-core CCDs, right? Like, I don't think there's a there's a concern for the the substrate of the chip degrading, right? Which would be the thing that carries more current as you add CCDs. Yeah, I don't think there's a concern for that, but I think there is a concern probably for the CCD itself, where if the CCD has less cores, well, there's less of a concern because it can't pull as much current. So a 3900X or a 3600 or a 3600X should have a higher fit limit in terms of voltages compared to any 8-core chip, like any 8-core based CCD. So like 3800X, 3700X, 3950X, those should have lower voltage limits for all core workloads. So yeah, that's just one thing I've been wondering about, which makes me really kind of like, I'm very strongly considering picking up a 3600 or a 3600X to mess around with, just so like I can do that kind of testing. Also because I've heard that the max PBO setting actually does something for 3600s, whereas it doesn't do anything for anything else, because apparently like the 3600s apparently just have really low boost limits, and so the boost override, like the clock speed raise set, like I can't remember. I think it's like max PBO clock limit or something. Like whatever it's called, apparently that works on 3600s. So that's the other reason why I'd like to maybe pick up a 3600. I'm just not entirely certain about that yet. Because the thing is just like, well, yeah, I'm not sure. Like, because at the same time, there's like other things that I could test. Maybe like, well, nah. It's probably a good idea for me to pick up a 3600. Anyway, so that's kind of some of my thoughts on like static overclocks with the voltages. Like, yeah, if you have a 6 core, it probably degrades slower than an 8 core CCD. Because I'd assume the degradation is current driven and not voltage driven, based on the fact that like idle voltages on well, it's not idle. Low load voltages, right? Like moving your mouse around, that's a low load. Low load voltages are very, very high on Ryzen just in general, which implies that the voltage tolerance is good. It's the current tolerance that isn't. Anyway, I'm gonna look at my notes now. Okay, save volts for static. Cool. Offset volts we've talked about. Edc bug we've talked about. Limits that work we've talked about. Oh, the one thing I wanted to talk about is I suspect the X570 Taichi does not obey AMD's stock power limits, because at stock it scores the same as some of my other motherboards with PBO. But I've not yet checked that the power consumption is higher. But I do remember reading some reviews that were like, yeah, ASRock's power consumption is higher on the X570 Taichi than everybody else's in like all core workloads, which is like they're probably violating the power limit, which is like you shouldn't be doing that out of the box. Like if you clear the CMOS, the board should be running at the CPU's power limits, not at its own power limits. Which basically means like I probably won't be doing an ASRock PBO limits video, because like if the board automatically sets the PBO settings above stock, then it's just like, well, what are you like? You're not going to achieve anything by adjusting it yourself. Like the board's already doing that for you. So yeah. What else did I want to talk about? That's it, I think. Is it? Yeah, that is. So, because we've talked about the EDC bug, which, in my experience, it's just too unreliable to recommend it to people. Also, oh, one thing I forgot to mention with the EDC bug is, one thing that it does consistently is it power throttles in Prime 95. So it's completely like, if you wanted to figure out your fit limits with the EDC bug, you can't, because it power throttles in Prime 95. Doesn't really, like, it doesn't seem to power throttle anywhere else if you get it working, but it doesn't work in Prime 95, so at all. So that's another reason where it's just like, yeah, the behavior is very strange and unreliable, so I just don't see a point in trying to use that, because, well, it's strange, like, it's unreliable. It's a bug. Like, I wouldn't really trust it to do anything properly. Yeah. Oh, wait. Okay. I don't know if I should go into this topic. To hell with it. Let's talk about it. So, I've been thinking about, like, how could PBO suck less? Okay, because let's be honest, PBO sucks. Or at least in my opinion, it sucks. And I've been thinking about that, and I realized something. The biggest problem with PBO... Oh, wait, that reminds me of the one other thing I forgot. How did I not... Well, this is the thing, is, like, I forgot to write that when writing the notes, and now I've remembered it. But anyway, so the one other thing I wanted to mention is... Wait, I think... It might have been a previous take of this video, but BCLK overclocking. Damn it, I can't remember if I said that already. Oh, well, if I've said it already, then we'll say it again, and I'll just try to go through it quickly. So, BCLK overclocking for Ryzen 3000 does actually work. the main issue with it is X570 motherboards suck at BCLK overclocking. So on my X570 Godlike, and it also again depends on the quality of your CPU, my 3700X is terrible. So, you know, even with BCLK overclocking, it just doesn't go very far because the silicon is just so very bad. I think if I had a better CPU, I could probably push the BCLK higher before running into the whole, well, it's just crashing in workloads. But, yeah, on Gigabyte X570 motherboards, BCLK overclocking just doesn't work at all. Like, my experience with it varies from not being able to get into Windows to not being able to get into the BIOS, which is just like, well, yeah, that does not work. Funnily enough, X470, like, I still need to mess around with that on X470 and B4, actually, B450 doesn't really have clock gens. But for X470 motherboards, I do want to mess around with it, which makes me kind of... Actually, I have an X370 board. X370 had one of the... Like, on X370, BCLK OCing worked pretty good, so I'll probably do it on X370. Because unfortunately, I don't have a... Like, I really wish I had a Gigabyte X470 Gaming 7. Because back on Ryzen 2nd Gen, that board was really good about, like, BCLK overclocking. Or no, my Ultra Gaming from Gigabyte was really good about BCLK overclocking, except that board's VRM sucked. So I really wish I had an X470 Gaming 7 so that I could do the BCLK overclocking with a board where the VRM doesn't suck. But yeah, I don't have an X470 Gaming 7, so that's a bit of a shame. But I do have an X370 Gaming K5, which is a even worse VRM than the Ultra Gaming. But hey, we can, like, I can work with that, right? Like, it's just for some quick testing. We're not actually, like, I don't actually, like, I just want to, it's more for a proof of concept than a actual, like, yeah, this is something you should do. Or, like, this is something I'll actually run long-term in heavy workloads. So, anyway, but BCLK overclocking on X570, in my experience, is just broken. It barely works. Lots of motherboards don't even have clock gens. So, yeah, I wouldn't bother with it. But on X470 or X370, BCLK overclocking can probably do a pretty good job of increasing, like, single-core and multi-core performance. Because the biggest issue with Precision Boost Overdrive is you can't actually offset the clock speed. And I know that might sound, like, weird, but if we compare Precision Boost Overdrive overclocking to the most similar other overclocking experience out there, it would be NVIDIA GPUs with Boost. And on NVIDIA GPUs with Boost, you have the power limit slider, which is basically the same thing as the, you know, PPT, EDC, TDC. You have the voltage slider, which is basically the same thing as the scaler on AMD CPUs. Both do absolutely nothing. So that's how you know they're the same thing, because, yeah, like, messing with the voltage slider on a 10 series NVIDIA card or a 20 series NVIDIA card does a whole lot of, like, it doesn't do anything. And similarly, the scaler on 3rd gen does nothing. And the power limits, well, you have a power slider on NVIDIA cards, and that works very similarly to the PPT, EDC, TDC. But you know what you don't have? That you do have on an NVIDIA card? You have a clock speed offset slider, right? And with the clock speed offset slider, you're able to do something that you can't do with Precision Boost Overdrive. At least not with the way AMD intends, like, it designed it. With the offset slider on an NVIDIA GPU, you can offset the core clock so high that the GPU will crash. But you can't do that on a Ryzen. The only way you're getting a Ryzen to blue screen from too much core clock is by tweaking the BCLK, because AMD, in their infinite wisdom, did not include a clock speed offset. They included the silly, like, max boost overdrive limit, but my understanding of what that limit is supposed to be is the maximum single core boost speed that your CPU is going to achieve. So, which is why it works on a Ryzen 3600, right? Because the 3600 has a really low single core max boost. So if you bump up the single core boost limit, well, your single core goes up on a 3600 and nothing else, because everything else already has the stock limit is about as high as it'll go. But on NVIDIA GPUs, you can just tell the GPU to run all workloads, all cores, at a higher frequency. And the closest you can get to doing this on Ryzen is, again, the BCLK overclocking, except it's horribly unreliable because you overclock your SATA, your PCIe, your chipset, which the X570 chipset just flips out if you try to overclock it. So, you know, everything gets very upset, and your memory gets upset, and the Infinity Fabric gets upset. So BCLK overclocking is not a good way of getting a clock speed offset on the core because it upsets everything else in the process as well. But on NVIDIA GPUs, you can just offset the, like, you can just set plus 100 megahertz or plus 200 megahertz. Or, and if you set it too high, like plus 300 megahertz, it'll just crash. But Ryzen, there's nothing you can do to make it do that. Like, there's no way to just tell the CPU to run, like, instead, because you can tell it to use more power. You can tell it to use more voltage, at least on paper. That's what the scaler is supposed to do. But similarly, the NVIDIA voltage slider is supposed to tell the NVIDIA GPU to use more voltage. It just doesn't. But so the scaler and the NVIDIA voltage slider are both like extremely similar. And I've only now realized the similarity. It's like, yeah, it's a voltage limit system that doesn't do anything. How have I never noticed this? Anyway, but on NVIDIA cards, you can just raise the clock speed and just tell the GPU, hey, instead of running 3D Mark Firestrike at, 2 gigahertz and 1.06 volts, try run it at 2.1 gigahertz and 1.06 volts. And then, if you're not happy with that, you can go, okay, now try run it with 2.2 gigahertz and 1.06 volts. Because again, the slider doesn't, like the voltage slider doesn't actually do anything. And now at 2.2 gigahertz, well, Firestrike is going to crash, and, it's going to tell you NVIDIA driver recovered, blah, 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 who cares. Point is, you can actually increase the clock speed. On Ryzen, you can't tell Ryzen to go, hey, instead of running Cinebench at like 4 gigahertz and 1.3 volts, you stupid pile of junk, how about running Cinebench at 4.15 gigahertz at 1.3 volts. Could you do that? Like maybe, just maybe that'll work. Which in fact it would, especially on my 3950X, that would actually work just fine. Like that chip can run Cinebench at, well, with 1.3 volts, it could probably do 4.4 gigahertz for Cinebench. And the thing is, there's nothing in the BIOS that allows you to do that outside of messing with the BCLK, except that makes the issue with messing with the BCLK is also it'll often make the CPU itself really upset. So especially on like Asus motherboards is where I ran into this. If you started messing with the BCLK, the CPU would just start lowering the ratio. So if you wanted to go from like if you were running Cinebench at 4 gigahertz, at like 40 times 100 megahertz, and then you raise the BCLK up to say 102, right? You would now be running, like, if it didn't lower the ratio, you'd be running at 102.5 megahertz, right? So that it would be a nice 4100 at 40x ratio. Well, instead of the CPU running at 40x, it would run at 39.5. So your actual overall clock speed would still be the same, but your BCLK would be higher, which was really, really annoying. Now, for whatever reason, when I was doing this on 2000 series Ryzen, Gigabyte motherboards didn't have this issue. If you raise the BCLK by 2%, like the clock speed just went up 2%. The main issue was that my 2700X was very unstable if you raise the BCLK more than like 3%. So it was, again, just like, well, do you really want to spend that much time fiddling with BCLK settings just for a 3% performance gain? Not really. And so, yeah, I think the main thing AMD could add to the Precision Boost Overdrive system is an offset for the clock speed. Not a limit increase, an offset. Straight up, just raise the CPU ratio by X value. None of this increase max limit by 200. No, just plus 25 megahertz at every single frequency setting. Now, the obvious issue is now you have to start doing stress tests because, well, if you raise the frequency of the CPU under all workloads by 25 megahertz, there's a good chance that now in some workload you're not getting enough voltage. And so again, like even if AMD did add a clock speed offset setting to the AGSA, it wouldn't change the fact that I wouldn't include that in a video for, beginners, because stress testing a CPU is not like stress testing a GPU. Stress testing a GPU is very easy. You don't run Furmark, for one thing, because Furmark power throttles like crazy on anything modern. But, you just run your workload, and the thing is, a GPU crashing is not very likely to cause serious harm, whereas your CPU crashing can cause some pretty major problems. And CPUs are annoying to stress test because you might be stable in 2-core workloads and 4-core workloads, or more like single-threaded, dual-threaded, triple-threaded. You get the idea. 32-thread workloads would also be fine, but then for whatever reason, if you run like a 15-thread workload or a 17-thread workload, that's unstable. And that's really like the biggest concern I'd have with a offset clock speed for PBO, is like, yeah, you now have to do a lot of really obnoxious stress testing. But I think it would finally make PBO into something more than just a disappointing way to raise the power consumption of your Ryzen 3000 series. In the process, best case, in my testing, best case scenario for PBO and XMP is like plus 10%. But if you actually had a clock speed offset setting, I think you could probably increase that to like plus 13%. Because I'd say there's probably like 100 to 50 megahertz headroom. And actually, what would be even cooler if AMD gave you a negative, like a clock speed offset for the entire curve, so you could just raise the whole curve up, but then the max boost limit for single core if you could lower that. Because what I would imagine would happen very quickly is you could end up in situations where like a 16-threaded workload is just fine, but a heavy single-threaded workload with a plus 200 megahertz offset would be extremely unstable. So then you'd actually want to lower the peak frequency while raising the low-end frequencies above what PBO is normally capable of doing. So, yeah, it's like I think PBO could suck less. It's just like at the same time it would include a lot more stress testing concerns as soon as like this was implemented, and that's the same those concerns also exist for any BCLK overclock. Like it's the same thing. If you raise your BCLK by 5% and across the board your CPU is now 5% faster, well, you have a very real problem of what if it can't do it can do 4.4 gigahertz on all cores, but it can't do 4.8 gigahertz on one core, right? Like that scenario is very, very annoying potentially with a BCLK overclock. So yeah, anyway, that's all of my thoughts for this. Oh man. See, I was very happy when there's been like 3 takes of this video. And I was pretty happy with like one of the earlier takes being like 35 minutes. But that take also didn't include all of my thoughts for like how to make PBO suck less. And all my thoughts on BCLK overclocking. And well, that's why it was 30 minutes instead of 40. 50. So yeah, anyway, this is the end. This is the end of the video. I don't have anything left to say. But yeah, hopefully this makes sense for why the PBO limit, why the PBO PBO setting videos I'm doing are the way they are. I know they're not very hardcore. I honestly do feel kind of bad about it, which is why this video exists now. But at the same time, it's realistically, if I was doing a personal, my own system, I really wouldn't do anything more. I would go either full static or just 300, 230, 230. Because I just can't be bothered with fighting AMD's boost algorithm. Because at least, NVIDIA's boost algorithm is annoying, but at least it's not, possessed. But AMD's is just, it does strange things for strange reasons. And I don't like dealing with that. Anyway, so, yeah, that's it. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below, which will help out with buying things like a... Man, I kind of want to pick up a 3600X instead of a 3600, but at the same time, realistically, most people are probably going to buy a 3600. Like, people are probably far more interested in the 3600. But anyway, so yeah, there's a Patreon. You know, it helps me do things like buying CPUs, that kind of thing. And there's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTube merch type stuff. And that also helps out with running the channel. So, yeah, that's it for... And hopefully, like, it won't go into making more videos like this. This I consider kind of a desperation video. But, yeah, and I really didn't want to be a talking head. So... yeah, it'll go into good videos, and not more of the easy way, like, well, there's going to be one more for MSI. I think for ASRock, I'll probably just do a video where it's like, oh, ASRock's BIOS limits are stupid again. Okay, I really should end this video, because I'm just going to extend it even more if I don't just hit the stop button at this point. So, that's what I'm going to do. That's it. It's over. I mean, I already did the outro and plugged all the merch and Patreon and everything, so, yeah, goodbye. I'm just gonna hit the stop button now. Thanks for watching.